Hello students, in the last lecture we have studied about type of adsorption. So two type of adsorption in detail we have studied, physical adsorption and chemical adsorption. Difference between the physical and chemical adsorption also in the last lecture we have studied, and after that we have studied different factors affecting the adsorption process. So there are various factors affect the adsorption process, like the nature of adsorbent, surface area of adsorbent, temperature, pressure or concentration of solution affect the adsorption process. Today we have to study adsorption isotherm, and after that we have to study what are the applications of adsorption. So first of all, see adsorption isotherm, a relation between the mass of adsorbate adsorbed and equilibrium pressure in case of gases, or equilibrium concentration in case of the adsorbate present in solution form. So at that time we have to take into account concentration of solution, and if adsorbate present in the gaseous state, gaseous form, gases, that is the pressure are taken into account. So that is nothing but the relation between the mass of adsorbate adsorbed and equilibrium pressure or equilibrium concentration at constant temperature is called as the adsorption isotherm. Because here iso means constant and therm means temperature. So adsorption isotherm means the relation between the mass of adsorbate adsorbed per unit mass of adsorbate and concentration at the equilibrium concentration or equilibrium pressure at constant temperature, that is called as adsorption isotherm. Now French studied the adsorption isotherm. So here we have to study French adsorption isotherm. French adsorption isotherm. So French studied the adsorption isotherm. The French adsorption isotherm equation is X by M is proportional to equilibrium pressure raised to 1 by N. Equilibrium pressure raised to 1 by N. So further this equation is shown, that is X by M is equal to Kp raised to 1 by N. Kp raised to 1 by N, where X is the mass of gas adsorbed, M is the mass of adsorbent, then P is the equilibrium pressure of gas, and K and N are constant. K and N are constant. That is, Fresnel studied the adsorption isotherm like this. According to Fresnel's adsorption isotherm, X by M is the adsorption. Mass of adsorbate adsorbed per unit mass of adsorbent is directly proportional to P raised to 1 by N. Here point to be remembered that N is greater than 1. N is greater than 1. Therefore, 1 by N is less than 1. तो जो N आहे, this N is greater than 1. Therefore, overall 1 by N is less than 1. So, why it is taken that we have to study later? I will explain it. X is the mass of gas adsorbed, M is the mass of adsorbate, P is the equilibrium pressure at which the gas get adsorbed, K and N are constant in that is they are constant. And here see, graphically also Fresnel's adsorption isotherm explained by plotting the graph of X by M versus pressure. X by M versus pressure is plotted, then a graph is obtained at constant temperature. That graph is called as adsorption isotherm, and this graphical representation of the law or this adsorption isotherm now we have to study. Here see the graphical representation. When we plot the graph of X by M means adsorption versus equilibrium pressure. Point to be remembered here, if adsorbate are gases, then pressure is taken into account, and if adsorbate are liquid solution, concentration is taken into account. Now when we plot the graph of log X by M versus P, then you will get this graph. So here at low pressure X by M is directly proportional to P. Okay, 1 minute. At low pressure X by M is directly proportional to P. At the moderate pressure X by M is proportional to P raised to 1 by N, and at high pressure the X by M is constant. What is its meaning? Its meaning is that at low pressure, in what extent we are increasing the pressure, in the same extent adsorption also increases, right? But from this up to here, in what extent we are increasing the pressure, in the same extent adsorption not increases. Means here what happens? When adsorption of gases take place on the surface of adsorbent, then the once or there is area or surface area when get covered, then the adsorption process becomes slow and slow. It will be decreases. Therefore, in what extent we are increasing the pressure, in the same extent adsorption does not increases. त्या एक्सटेंट मध्ये adsorption increase नाही होते, आणि adsorption जर त्या एक्सटेंट मध्ये increase होत नाही, म्हणजे P raised to not 1, P raised to less than 1. Therefore, Fresnel studied the adsorption at moderate pressure. Fresnel studied the adsorption at moderate pressure, and yet here you see at high pressure there is no change in the adsorption, so X by M is constant, and this is studied at the constant temperature T. So this graph obtained is called as adsorption isotherm. This graph obtained is called as adsorption isotherm. Now see, this is equation number 1. Taking log on both side of equation 1. What we will get? That is the log x by m is equal to log k plus 1 by n into log p, right? Here this is the equation y is equal to mx plus c. This is the equation of what, that is the straight line, equation of straight line, and therefore here we have to confirm it. That is when log x by m is plotted versus log p, then a straight line is obtained which does not passes through origin. That does not passes through origin. Here see, this is nothing but another one graphical representation of French adsorption isotherm. Here on this axis we have to take log x by m, and here on this axis we have to take log p. So when we plot the log x by m versus log p, then we will get the straight line which does not passes through origin. Intercept on this y-axis gives the value of log k, and slope of this straight line gives the value of 1 by m. So that is nothing but what, that is the French adsorption isotherm. In this equation we have studied log x by m is equal to log k plus 1 by n into log p. This is the equation of what, that is the y is equal to mx plus c type. Y is equal to mx plus c type is nothing but the equation of straight line. So confirm whether this equation is of straight line or not. How will you confirm? Plot the log x by m versus log p, then you will get straight line which does not passes through origin, and therefore here log x by m versus log p plotted, straight line which does not passes through origin is obtained. Intercept on y-axis gives the value of log k, and slope of this straight line gives value of 1 by n. So this is nothing but the overall, that is the adsorption isotherm, and it is the French adsorption isotherm. It is the French adsorption isotherm. Now see the next one point. Here we have to study applications of adsorption. Applications of the adsorption. Adsorption found the many applications in what, that is the many fields. First one, like what, that is the catalysis in specifically homogeneous catalysis. There is use of adsorption process, as well as in heterogeneous catalysis also the adsorption process is used. How? That is catalyst used in the chemical reaction in finely divided form, in finely powdered form. What happens? Reactant get adsorbed on the surface of that catalyst, due to which concentration of that reactant reagent increases and the rate of reaction increases in the presence of catalyst, because that reactant forms intermediate complex with the catalyst, and therefore it immediately decomposes and gives the product. Therefore, in the presence of catalyst, reaction rate increases, and in this catalysis adsorption process is used. You see, simple example, that is CH2, double bond CH2, hydrogen gas, ethylene gas, in the presence of nickel as catalyst. In the presence of nickel as catalyst. So what happens? Ethylene gas and hydrogen gas get absorbed on the surface of nickel catalyst. So adsorption takes place, and then addition of hydrogen takes place in ethylene and ethane is obtained. So in this way, in many chemical reactions where the catalysts are used, the adsorption process is used. Adsorption process is used. See, another one, what that is the applications of the adsorptions here we have to study. That is, second one application of adsorption is in gas mask. There is use of adsorption process in gas mask. So in gas mask there is activated charcoal. Activated charcoal is there, and what happens? This activated charcoal absorbs the poisonous gases like the carbon monoxide or sulfur dioxide. So what are the gases present in polluted air? When we use the gas mask, then that gas mask contains the activated charcoal, and this activated charcoal absorbs that gases and protect us. So therefore, that is the important application of the adsorption that is used in gas mask. Also, to control humidity, there is use of the adsorption process. Silica and alumina gel are good adsorbent, and they absorb the moisture from the atmosphere, and therefore they control the humidity. They controls what that is the humidity. Then see, next one, application of adsorption to produce high vacuum. There is use of the adsorption process. हाय व्हॅक्यूम प्रोडक्शन मध्ये ऍब्झॉर्प्शन प्रोसेस यूज होते. कशी यूज होते? सपोज फर्स्ट ऑफ ऑल एयर is removed by using the vacuum pump. First of all, air is removed from the chamber, from the container, or from a room. Okay, from a cylinder, from container, air is removed by using the vacuum pump, and then that container in which we have to produce the high vacuum is connected. It is connected to another container or cylinder which contains the adsorbent like the charcoal, activated charcoal. So what happens when one container is connected to another container? That vacuum container is connected to another container containing the charcoal. So if any gases left, air left, that will be get absorbed on that charcoal, and then we have to disconnect it. So high production of vacuum is take place. म्हणजे तिथे बिलकुल गॅसेस किंवा एअर शिल्लक राहणार नाही. So in the high production there is use of the adsorption phenomena. Then Next one, that is the adsorption indicator. Next application is adsorption indicator. There is use of the adsorption phenomenon in the acid-base titration reaction. There is use of indicator. And what happens? This indicator means which indicates the end point of reaction. It indicates the end point of reaction. Reactionचा end point ते indicate करते हैं. आणि reactionचा end point indicate करण्यासाठी we are adding one drop of indicator in that reaction mixture. And when completely 10 ml pipette out substance if treated or reacted with the substance filled in the funnel burette, when that 10 ml substance completely reacts, then there is formation of a specific color which is called as the end point, and that is indicated by an indicator. So how it does indicate? That is, that substances get absorbed. On the surface of this indicator, and it shows the color change. So in that process there is use of the adsorption indicator. So precipitation titration मध्ये त्याचा यूज होतो. Precipitation titration is used in it also. For example, that is the sodium fluoride when treated with silver nitrate, then it produces the sodium nitrate and silver chloride precipitate out. That is the, in this reaction, fluorescein indicator is used. So what happens when there is formation of precipitate of AgCl? This fluorescein indicator gets adsorbed on the surface of the AgCl and it shows the color change, end point of the reaction. Therefore, in adsorption indicator, acid-base titration, precipitation reactions, there is use of the adsorption phenomenon. So here in this case, when fluorescein gets adsorbed on the surface of AgCl, it indicates the reaction end, that is the end point of reaction, by forming the red color. Red color form करतो आणि reactionचा end point इथे indicate होतो. It indicates. Then what, that is the next one application, separation of inert gases. The inert gases obtained from the air contains the inert gases. They get absorbed on activated charcoal, and they have different rate of adsorption. Therefore different rate of desorption also, and therefore they can be separated one by one by adsorbing them on activated charcoal or animal charcoal. म्हणजे आपण ज्यावेळेस गॅसेस एअर मधून सेपरेट करू आणि मिक्सचर ऑफ इनर्ट गॅसेस गेट adsorbed on the surface of activated charcoal, and they can be separated by using their different rate of adsorption. See, another one application, that is in the froth flotation process. In the froth flotation process, there is use of what, that is the low grade sulfide ores are concentrated by this method, and in this method there is use of mixture of fine oil plus water, and that finely powdered ore is agitated in the presence of fine oil and water. So what happens, that ore get absorbed on the surface of this fine oil, that weighted by the fine oil, and in that process the adsorption process is take place. So the matter like the silica, impurities or glands which are present in it, they are settled down at the bottom. Ore particles are weighted by fine oil and they comes in the froth, agitation in the presence of forced air. ते कशामध्ये येतात, froth मध्ये, and then they are separated. So within this process adsorption of that oil is take place on the surface of that ore particle. So here also there is use of adsorption process. And last one application is that in the chromatography, also there is use of the adsorption process. In chromatography, like the column chromatography, then what that is the thin layer chromatography, or what that is the paper chromatography, there is use of what that is the adsorption process. In that column, silica gel or what that is the alumina gel are placed, and they are used as adsorbent. Chromatographic technique is used for the separation of the mixture of substances. When that substances are present in very less amount in that mixture, then at that time there is use of the column chromatography or the other paper chromatography. But what happens, later we have to study in this chapter chromatography. What happens, that mixture is poured in that column and they get absorbed on the surface of the silica gel or alumina gel, and their rate of adsorption is different and they form different color bands and hence they get separated. So in column chromatography technique is preferentially based on preferential adsorption of that ion. It is based on preferential adsorption of the ions on that silica gel or alumina gel, and these are nothing but the applications of adsorption. So it is found application in catalysis, as well as it is also useful in gas mask to control humidity, to produce high vacuum. In adsorption indicator, precipitation titration, there is use of indicator, and that phenomenon is based on adsorption, separation of inert gases. Inert gases adsorb on the surface of activated charcoal, and then they have different rate of desorption and they get separated. In froth flotation, low grade sulfide ores are concentrated by froth flotation process. Concentration is the process in which impurities are removed, and chromatographic technique also based on preferential adsorption of the ions. Okay.